Welcome everyone to today's brown bag activity. Today is going to be some really cool information for you. And in fact, I'm looking forward to it as well. Today we are having tours and overviews of all the different labs and makerspaces that you can have access to as a College of Engineering student. You are going to get to hear from a variety of folks in different departments who are going to tell you about what's available to students in their department and, maybe even other students if you're working with their department. So we are going to hear from the CSE department today, the EE department, the IMSE department, and the MAE department. Each department's going to have about 10 minutes to tell us about their lab, and then we'll have a little bit of time at the end for questions and answers. So if you have questions today, please put them in the chat and we will be able either to get to them. If we don't get to them during the presentation, we'll make sure we get answers back to you after that. So to start us off today, we're going to begin with our computer science engineering department. Our walkthrough of the lab is going to be led by Dr. Chris McMurrow from CSE. So Chris, take it away.
Hey everybody, hope you're doing well. So I'm going to show you just a quick walkthrough of the CSE EE MakerSpace. This is not just because it's the CSE EE MakerSpace. That's what our equipment focuses on, but it's open to any engineering student, or really any other student for that matter. So a lot of our stuff kind of focuses on circuit board prototyping, rapid prototyping with 3D printers, laser cutters. We have some typical kind of machine shop tools, like a kind of a small set of those things. So we've got a lot of stuff here for you guys to make whatever it is that you're working on for class projects, entrepreneurship stuff, extracurricular projects, competitions. We can support all those things here. So I'm just going to kind of walk you around the lab and just sort of point out some of our key features here. If you have any questions later, feel free to send me an email. If you want access, you can send me an access request. It's mcmurrow@uta.edu, and we can talk about getting you trained and getting you access to the lab. So I'll sort of start over here. We have a bunch of electronics prototyping benches here. So we've got your typical power supplies, oscilloscopes, multimeters, all that sort of bench test equipment that you would expect. This is all really good new stuff too. We have a spectrum analyzer. We've got some other fancy stuff there that honestly I don't use all that much, but some of the EE people use a whole lot. So we have all this stuff. Over here we've got surface mount soldering and through hole soldering capabilities. So we've got your typical soldering irons, regular old soldering irons with different tips and stuff. But we also have hot air rework stations. So with these hot air stations, you can actually do surface mount circuit boards. We have the ability to mill those circuit boards here, or we can outsource them to get something like, say, this. And then we can actually do the surface mounting of the chips on there. And we can get really professional looking printed circuit boards using this equipment here. It's actually a lot easier to do than you might think. So we also have the ability to bake our surface mount boards or through hole components in here to do the soldering. And we also have your traditional, hand soldering tools as well. We've got band saws for cutting PCBs. We have pick and place machines. There's actually two of them. That's an automated pick and place machine for doing like large batches of circuit boards. This is something that's really kind of only used for like very special purposes. But we also have an assisted manual pick and place machine. So over here, this helps you to accurately position, I don't know if you can see that circuit board there, but you can really accurately position very complicated chips, microprocessors and stuff onto a board. So we can actually do really professional looking soldering work here. So now I'm going to move on to kind of some of our other types of fabrication. So we have 8 Ultimaker 3D printers here. Get a good picture. So those 3D printers are running almost all the time. We have some staff assistants that help us keep them running. We also have some students that use them regularly that keep them running. But those are available. We actually have some funding available for materials, so plastics and wood and stuff like that, aluminum. We can actually, through our budget, pay for some of those materials. So you can actually 3D print things here for free, within reason, of course. Okay, we also have a large format laser cutter. We can cut wood and plastics with this. It's a very fast process. So, big sheets of wood and plastic like that, we can cut through them no problem. We have very accurate SLA 3D printers. These are like resin-based printers. They can do really accurate models for more like if you're making engineering components or something like that. And then we also have your typical kind of machine shop stuff over here, drill presses, band saws, lathes. We have a CNC mill for aluminum parts. So we have some, really capable stuff over here. These are the circuit board mills I was talking about earlier. So we can actually take copper clad board, and you can come here with your circuit design and you can mill it out on this machine, and then you can go solder it across the hall or across the room, and you've got your circuit ready to go same day. And then we have a workspace. We've got a TV here for meetings. We've got general workspace there where you guys can come and meet with your teams or come here and study, whatever. We're here for you guys to support your projects and your work. So that's all I have today. If you have any questions, again, send me an email. It's mcmurrow@uta.edu, and enjoy the rest of the tours here.
Hey, Chris, what's the room number for your lab?
Oh, yeah, that's probably important. It's Niedermann Hall 241. So second floor of Niedermann Hall, kind of in the middle of the building.
Thank you. All right. So it was really interesting. You all can't see all the faces that I can see, but everybody on the tour is intently watching everybody else's tour too, to see how much more resources we have than we even all knew about. So our next presenter will be talking about more resources for our electrical engineering department. So our presentation is by Todd Kelly. So Todd, we're going to let you take it away now.
Well, thank you very much. So the electrical engineering MakerSpace is kind of a subset from this larger MakerSpace that Chris just talked to you about. We have a lot of the same machines, and we have a lot of specialized machines for specific PCB design. We also have workshops that we offer our students to learn microcontrollers and different sensors and motors, and learn how to control and build different projects. I'm going to go ahead and play a video for you that sums everything up pretty succinctly. Okay, here we go. Hi, I'm Todd.
I'm Matt.
And we're here to talk about the UTA Electrical Engineering Labs and what they can offer you and the different equipment that we use. Then I guess we maybe cut to the other stuff. I guess we could talk about this stuff back here. This room is Niedermann Hall 128. This is for design students. We have 4 1 gigahertz oscilloscopes, which is, if that doesn't impress you, I don't know what will. We have 4 very powerful computers with all the software that the university offers. There's power supplies, there's meeting spaces, there's a projector, screen, glass dry erase boards all over the place. So this is for you to plan your projects and to successfully complete them. Successfully. Let's go over and look at the MakerSpace right now. Okay, here we have Niedermann Hall 131, the electrical engineering MakerSpace, which is just for electrical engineering. There's a larger one upstairs. We have PCB fabrication in this room. We also have, these are our 3D printers. They are incredibly fast and very useful. They print ABS and multiple other materials. Over here we have a couple of the, let's call them beginner PCB designed milling machines. So you can print out make your own PCBs here. These are some of our 3D prints from the poly printer. This one just shows you how much it can overhang before it actually needs any kind of supports. It's actually pretty impressive. This was made on our poly printers. This is what we call Ninjaflex or TPU. It's a flexible material that you can possibly make gloves or different things for your projects that need the flexibility. This is just a standard XYZ cube, so you can calibrate the printer for dimensional accuracy. This is some sort of holy duck. And of course, let's talk about, so the milling machines we were talking about, you can actually go in and design a circuit in your software, bring it out to the milling machine, and it will actually
cut off the copper that you don't need and leave the traces that you need. You can make double-sided through-hole PCBs. We'll talk about this real quick. Upstairs, there's a makerspace between CSE and EE, ran jointly for the entire College of Engineering, and their 3D printers are the Ultimaker S5, I believe, and they can actually make complete 3D prints that do not need assembling because they have two print heads. One of the print heads prints in like a sugar-based soluble substance that can support all of this as it's printing, and then you simply rinse with hot water and remove all of the soluble infill. It's not really infill, it was support. Okay, this may take me an hour or two to get this back on here. Seriously. Let's open up this here. If you ever need tools for your projects, we do have a room called the old wood shop. One thing I forgot about over here is we can cut aluminum extrusion, so you can design your project with a very sturdy frame, especially if you decide to make a 3D printer or milling machine yourself. In here, we have a sliding radial saw for cutting aluminum extrusion or wood or anything else that you might need. We have a normal table saw, sander, a drill press. Sometimes we may need to open up a hole in a PCB to fit a component properly. Lots of connectors, drills, air compressor, nail guns, socket sets, tap and die sets, pretty much anything that you'll need to complete your project. And this is all available to you through the EE Labs. Behind you, we have just purchased a very expensive PCB mill. This is probably going to be for some junior design students or senior design students that have to make very, very small, intricate PCBs. This will actually print on true FR4, which is a real PCB material used with radio frequencies or any high-speed electronics. You will come to the EE staff and we will run this for you to print your PCB. It's pretty complicated. Over here, this section over here is whenever we're done with your PCB, you can add the green masking and the lettering that you see on completed finished PCBs. That way you know where to put your components. Are we still on? Okay, our Electromagnetic Slab, we have 4 benches set up with powerful PCs that have ANSYS electromagnetics program on them that you can design and simulate RF devices, antennas, and different things. That's pretty industry standard, and it's a really good thing that we have that development skill brought to our Electromagnetics lab. So not just simulating it, over here you have spectrum analyzers, high frequency signal generators, and of course your standard lab setup. This will allow you to measure the high frequencies and see how they respond to different materials. Okay, we also have 4 high frequencies network analyzers that go up to 6 gigahertz. You'll use those in the electromagnetics class to characterize antennas to see how they respond to different frequencies. And that comes complete with different calibration kits to use with them. We also have portable nano VNAs that we can issue to you in electromagnetics, so you can take these home and get more experience with them. So they're similar to the expensive ones I just showed you, but these are portable. We also have a Autonobots club that you can join, that you will be able to program autonomous robots such as this little turtle bot right here. Here we have the senior design room. The senior design room is loaded with specialized equipment, but it's also going to our through hole plate. So what this piece of equipment does is when you design a double-sided PCB, you drill the holes in the PCB. Those holes have to be connected. We have to electroplate those holes with copper so that the copper top and the copper bottom connect. And that goes through a chemical bath where we do electrolysis to do that. So after we drill the holes, we through hole plate the PCB, then we have to bring it back and do the milling of the actual traces. We have 3 solder benches, each which has 6 stations. We do offer solder classes where you can come in, grab a toolbox, follow along with the videos, and learn to solder at your own pace. We also have a solder 3 class that teaches you how to solder using surface mount devices. It's one of our workshops. All right, in Niedermann Hall 148, we do have open lab hours in this room from time to time. When we're not having open lab, we have different classes in here, such as controls. This room has 13 benches, just like 129A, all standard equipment. And we do have workshops on how to use said standard equipment. The controls class that is in here, you will learn how to control electronics with precise precision. So this little Quanzler cube servo is programmed to precisely control the balance of this little rod.
Up here in Niedermann Hall, room 241, we have the shared makerspace between CSE and EE. In this room, we have more test equipment. So if you are building a project, need to finish your project. We also have hot air soldering. So that is the specialty solder type that you need. We have the ability to mold in plastics on this Formac 450. So if you need to make plastic blow molded or vacuum molded objects, we have all the parts and equipment that you may need to finish your project. So if you need a transistor, resistor, whatever you may need. We also have a assisted placing tool, so vacuum assisted placing tool. So if you have a really small PCB board that you're placing parts on. We also up here have a laser printer. You can print 1/4" plywood and fillet. So you can make pieces for your project. Here we have a bank of SLA printers. SLA printers are liquid, so they are a little bit different than the printers downstairs. So they print with a resin and put out small, very precise print products. And then also we have some physical manufacturing tools. We have a drill press. We have a bandsaw. We have a tabletop CNC. So if you need to CNC some wood. We also have, if downstairs is full, we have 2 more tabletop CNCs for milling PCB boards. And then into the larger manufacturing section, we have a programmable CNC machine here. We have a manual mill and a manual lathe. Middle here, we have a bank of 8 Ultimaker 3D printers. So downstairs, Todd was talking about the 3D printers that print in PVA, which is a dissolvable plastic. This is where you can print the plastic.
All right. Since
So,
I've stopped sharing my screen here,
so Todd, a quick question. What do students have to do to get access to those lab spaces?
these labs are specifically funded by the lab fees for electrical engineering. So to get access to this, one, you can become an electrical engineering major, intended major, or two, we can work with other departments. We may have to charge a small fee for the materials.
Excellent. So would they contact a particular faculty member? Would they contact you? Would they contact
either me or Adam?
Okay.
Yeah, either me or Adam.
Awesome. Okay. So anything else you want to share with us?
Besides that, electrical engineering does offer the workshops for the undergraduate students for Arduino, how to make cables, how to set up Raspberry Pis and automate different tasks. Besides that, we do have a fairly extensive YouTube channel where we go over how to change cables, how to solder. Just for anybody that is interested can browse that and see a little bit about what electrical engineering is like. And you can also visit the UTA EE Lab homepage, or if you're interested, you can actually book a tour and come down and I will walk you around the labs and show you myself.
Perfect. Thank you so much for filling us in on everything electrical offers to their students.
You're welcome.
And might share with the rest of us. We appreciate it. And now we're going to move to our Industrial and Manufacturing and Systems Engineering Department. Dr. Brian Huff is going to tell us about the resources they have available for students. Brian, you're muted.
The first thing I would like to say, but can't because I'm muted, is that, why sit here and watch my PowerPoint presentation? We need to go out and start using these labs. So I'm really kind of impressed. I'm going to go here and share my screen and pull up a presentation pretty quick. Okay. So, and Dr. Tiernan, if you can tell me whether we are projecting the presentation.
Yes, we've got it perfectly.
Okay, well, great. The only problem is it's on the last slide instead of the first slide. So let me work on that for just a second. Okay. So what I'd like to do is to introduce the Industrial Manufacturing Systems Engineering component of the College of Engineering MakerSpace. And in that space, we kind of focus on 3 different areas. I have a passion for automation, both factory automation and autonomous unmanned systems. And a lot of the work I have in my lab attempts to look at the systems view of implementing those things. This was set up to sort of meet the needs of a strategic priority of the College of Engineering, which is to provide sort of an enhanced experience for our students through the ability of doing extracurricular work, get hands-on student competitions, those sorts of things. And I focus this lab to really support a series of research focus areas. And my 2 favorite out of these would be the autonomous or automation systems and the manufacturing subcomponents. Okay, so really I'm interested in, again, the creation of automated and autonomous systems, and to support that in the most widely used component of this is sort of like a lending library where we have various components of these systems for unmanned systems, autonomous systems, and automation, and we make them available to teams of students that are working on specific projects to do that work. And I'll talk more about that later. We also are interested in supporting what we found in our efforts to make these systems is that we as students, as researchers, tend to rely on what I call basically artisan craft-based manufacturing techniques. And unfortunately, we need more precision than that. So I'm looking at the idea of using industrial automation in ways that we can make small-scale quantity productions of elements using industrial automation. And then to back that up with the metrology that we need to basically be able to measure what we produce so that we can sort of do the work that hold the tolerances that we want. So we make available for people, to teams of people to set up automated systems, use various sensors with that automation to be able to do precise automated production. Okay, and I'm going to basically, we've done a lot of support, so for various student projects, give us some quick examples. This is an example of a senior design project that I did in conjunction with Dr. Woods at the MAE department, where we decided, again, that we wanted a system that we could take to College of Engineering recruitment activities that could basically scare little kids and their parents of various recruits to the UTA engineering department. And this is a system, this system was kind of built from scratch by the MAE students. Now to talk about this, this involves basically 18 different actuators working in parallel, where the students basically designed and built up the actual mechanical structure, but more than that, did the mechatronics required to drive those systems. Another example of a MAE senior design project that I had the ability to, or the honor to work with, was for an indoor mapping robot. And the idea here was, how can we quickly create 3D virtual environments that we can then use for tours? And so this team basically first went in and came up with a system to autonomously control the cameras, so to take all the images required to get the inputs to make these 3D images or these models. And then once they figured out how often and resolution and the control of these cameras, the next phase was, well, how can we cover large areas? So let me stop this here. And first we had to, I don't want to manually control these systems. I want to be able to automatically design the control system. So to basically figure out where we would have to take pictures and in what quantity to stitch together, and then how to drive the actual mobility platform to do it. So on the left here, on the right here, is a picture of the actual mobility platform following the path that was automatically generated to actually cover a large area. And then the last slide here actually shows sort of what they were able to create. So now that I have that model or information, this is their ability to go in and stitch together all those images of the 4th floor of Wolf Hall and then show what that looks like. Now, the first thing I want to point out is, if you look at this, you can say, you know what, there's some problems with this, okay? And I agree that there's problems with this, but as senior design projects, we only have a semester or two to work on these problems. We don't expect a perfect solution, okay? But just think what we've created, okay, with the time and effort that we have, you know? So I think these efforts, even though they might not end up being exactly what we want, can be really kind of fun and interesting solutions. Okay, so let me stop that. So we also provide support for specific classes out of this. This is the lending library. So we mentioned the senior design classes. We've also provide information or resources for our Unmanned Systems Certificate Program. This is a small team. We basically lend to that class some of the sensors and some of the controllers needed to build these platforms. And then we also support projects. This is current ongoing mechanical senior design projects where they want to create an autonomous wheelchair. And then in my automation classes, we're also looking at, again, system level solutions to do automated beverage servers, autonomous gum removal systems, indoor tour guide systems. And then also, although we haven't done this recently, we've also used these resources to support student competition efforts. These are a list of some of the competitions that we've supported. So we've built robots for NASA competitions and aircraft for the AUVSI, unmanned aerial system competitions, and roboboat competitions. So I think that's all I have here. So if there are any questions, I'll be more than glad to take them. Turn over.
So I think at this point, we're going to go ahead and finish out presentations, and then we'll do questions at the end.
Right.
So thank you much, Dr. Huff. And our final presenter is Dr. Robert Woods, along with Rex Winfrey, who will be presenting about mechanical engineering lab opportunities. And Bob's getting his PowerPoint set up. We're seeing his picture of himself with his Ford GT40 on his computer there.
Well, I'm trying to share my screen, so maybe I'm doing something wrong.
So we're seeing.
Dr. Woods, you're just going to walk around your lab, correct?
Yeah, maybe I don't need to show my screen.
Yeah, I don't think you need to share your screen. You can just hold your camera, your laptop up.
There you go.
All right, so I hope you can see full screen, but I want to show you, this is our Design Innovation Lab, room 108 of Wolf Hall. And I'm going to introduce you to Rex Winfrey, who will give us a guided tour.
Welcome to the Design Innovation Lab. The lab is an additive and subtractive manufacturing facility. One half is 3D printers, the other half is a full machine shop. And come around here, this is the Aeon M2. It's FDM, it's very large. Build area is 18 by 18 by 25 inches. They can handle anything from PLA up to Peak and PEC and Ultim. It's a very, very good machine. Over here this is for cleaning up what's going on with the centric Lisa. This one is SLS, so it prints using a laser beam to melt the nylon into different parts. This printer is used for special projects where they're printing powdered material into the filament, and then that way they can fuse it later into a solid object.
They used copper this last time, right?
Yes. I've got two computers over here for students to use. Got a Mark Forged printer that it can print with nylon. We can also add fiberglass, high temperature fiberglass, Kevlar, or carbon fiber into the prints. And my desk around here. This is the HP Jet Fusion 580 color printer. This thing is it's big, but it's very, very fast. It's the fastest printer that we've got. And we have printed as much as 2 aircraft that were 24 inches nose to tail, 42-inch wingspan, and printed 2 of them in 12 hours. And then over here we have, we've got 3 SLAs. This one is DLP SLA, so it flashes the entire image of each layer, so it can run a little bit faster. This next one is a Form Lab Form 3, and it has a higher resolution laser. The Form 2 is one of the earlier models of them, and then the cleaning materials to take care of that one. And here on the machine shop side, we've got a large, very large mill, and this work table here got a 3-in-1 machine, so you can shear metal, bend it, and roll it into whatever shape you need. We've got one bandsaw for cutting metal and aluminum, and then this one up here is used for cutting plastic and wood. This is our injection molding machine, and with this one we can use the form labs and design the molds, and then put them in here and injection mold, make the parts they want to make. And this part over here is all the welding equipment.
Bob and
Yes.
Rex, your video looks like it's locked up on my screen. Tracy, are you seeing the same thing?
I am, and I'm actually seeing, yeah, it's coming in and out. It may be a UTA Wi-Fi issue.
Yeah. So now it's live again.
Okay.
In here we've got everything. We can do oxyacetylene, stick welding, MIG welding, TIG, different, almost every type of welding that you can do, except for laser, which is in a different lab. This is for cleaning up the parts when they come out of the HP printer. We've got a furnace right here, and that one is for doing things like sintering metal together or doing heat treating on the metal. This one goes up to 1400 degrees Celsius, and we can put different gases through it to control things. Our lathe is right over here, and it's an older machine, but it gets everything done that need to get done in here. Then we've got a large drill press and a bench grinder, and then around here is where we've got toolboxes and stuff over here. This is the barrel arm, and it is built so that you can either use it just as a touch point, or you can scan with the laser and it'll pick up 43,600 points per second. And it can tell you exactly how far apart different areas are. You can take the data from it and compare it to an original part, and it'll show you the errors that are in it. And then they can also take that and create a model that they can use to actually make some of the parts for things like the formula team. And in here, they can also make parts with it. One of the things that the HP printer can do, that is the only printer that I know of that's here that can do it, and that is to be able to print objects within objects so that they cannot be removed. This little HP logo. This was all printed all at once. And
In color.
yes, in color. We can print with any color we want to use. But we can make all kinds of things in here. It's people would come in and, can this be done? I'll tell them, yeah, we can do it.
Okay, thank you, Rex. That was a great tour. We have a lot of capability and facilities here. And I'm sure she's going to ask, who can use the lab besides you?
The students can come in and use it for their senior design projects and capstone, and then all the different competition teams. I've worked with them quite a bit to do the drones and the rockets and everything else.
But to use some of the more sophisticated machines, they have to be trained by you.
Yes.
Then they can use the machines. Okay, that's it for us. Any questions?
All right. So thank you so much, Bob and Rex. So we do have a few questions. We have one question to start off with for Todd, because Todd mentioned specifically training classes that are available in EE. So the question was asked, is there a schedule for when you offer the classes, or do you offer the classes just as needed?
It
so
is.
Todd, if you're answering and you want to turn on your camera, that would be great.
Yeah, can you hear me?
Yes, we can.
Good. I'm going to post a link to on our lab website. There's a button that directs you to the workshop schedule of what we offer and when, and you have to sign up through that.
Perfect. All right. So this is a question for everyone. EE definitely mentioned that their facilities are primarily for EE students, although there would be ways to potentially make arrangements for other students. What about in the other facilities? I know Dr. Huff mentioned that he has worked with other groups, but are you primarily working through faculty, or can students contact you? And then same question for MAE, what students are able to come and work in your lab area? So Brian, why don't you start us off?
Okay. Typically the way that I've worked in the lab, a lot of the resources in my lab require some study and time to get up and work. And typically the time frame for my lab activities have been sort of like the semester projects or 2-semester senior design projects. And typically what I'd like to see is a group of students who basically have some sort of faculty sponsor, okay? That basically, and then I can go ahead and set up. Sometimes that faculty sponsor is me, or if there's another group from outside, if I can have a faculty sponsor that says, hey, these students need to do X, then I can work with them to try to get set up and get it done.
Excellent. Thank you so much. And Dr. Woods and Rex, what about students accessing the equipment and facilities in your lab?
Yeah, just as I would like to use the double E's facilities, build circuit boards and so forth, we will make the same available to any major. They have to first clear it with me through their faculty advisor, and then we can build parts for them.
Okay. Excellent. Thank you so much. So in these various labs where there are materials consumed, who pays for the different materials that are used? And Dr. Woods, you guys may want to mute your sound when you're not speaking because we're getting a little feedback from you. Thank you. So I'm going to kind of go through each of you. I noticed Chris is not with us, but Todd, you're familiar with the CSE EE lab as well. So Todd, remind us again, how are materials paid for if people come and work in either the CSE EE shared lab or in the EE labs?
For the upstairs CSE EE lab, that is paid for by the dean. So that is open to virtually everybody on campus.
Awesome.
For the electrical engineering workshops, I was just typing this up, the workshops in the MakerSpace are free for electrical engineers and the electrical engineering intended students that are working on projects. Other departments can come by and make anything that they need, but they will have to be charged for materials for it.
Awesome. No problem. Thank you. Brian, are there any fees associated in using the resources that your labs have?
I encourage that we let Dr. Woods go first, and then I'll answer that question.
Awesome. All right, Dr. Woods, fees associated with using your labs.
Well, again, we're funded by the Dean of Engineering, so expendables and a little bit of expense is okay. Dean will be covering that. But when it gets to be a substantial amount of equipment, facilities, or hardware, we'll have to charge something for that.
Thank you. All right. And Brian, did you have any follow-up?
Yeah. Well, I guess my view is I needed the answer to that question myself, because currently I don't have a budget for materials out of the lab. So we have been paid, people we pay out of, I don't have a budget from my chair or the dean at this point. So I need to understand how that mechanism works. We pay out of on a project by project basis. So yes.
Okay. All right. Thank you so much. So I think you addressed this, but just to clarify, if students are interested in using the resources or tools available, but they're not in any particular class, or they're not working with a specific student organization or team or faculty advisor, would they still be able to use your resources? And let's go to Dr. Woods first. So let's say student X comes by and says, man, I really want to use machine Y. What would be the process?
The original intent of the MakerSpaces in terms of the dean's vision was that people could use it for entrepreneuring. And so certainly a student comes in, has got an idea not related to a class or a team or a project. We're supposed to support that. But, you know, that's a little bit different because, you know, any expenses out of that probably needs to be borne by the student. Otherwise, they would say, I want to build a full-size airplane.
Right.
Can I use machines? So that would, again, have to go through me, and we would have to evaluate what the time and the cost will be. But the dean intended this to be for innovation for personal students. So we need to try to support it within reason.
Excellent. Excellent. Todd, what about students, those particularly those EE students not in a particular class, or those non-EE students who might be interested in using your resources?
Like Dr. Wood says, we could usually try to support everybody up to a point.
Right.
We can't bear the cost of too many things, but if anybody needs maybe some simple connector put on with some of our specialized tools, then yes, we're more than willing to do little things like that for people.
Okay. All right. And Brian, if they have this amazing idea about autonomous robots, can they just come randomly borrow things from you guys, or?
Well, I guess we have not historically done that.
Right.
And the reason we have not historically done that is I found that these systems take a lot of time and effort to put together.
Right.
And particularly if they move around, and particularly if they fly, the relative risk associated with getting the components back is very, very high.
Right.
So as a result, we tend to work with teams, and they have been working on a sort of a mission, or that has been thought about, justified to go forward.
Awesome.
So that's how I've tended to work.
Okay, that's a perfectly reasonable approach, and I think that makes good sense, and our students could certainly understand and work within those guidelines. So here's another general question. We all know, of course, that our library also has a MakerSpace. Do you guys feel that there are occasions where the library MakerSpace might be a better fit for a particular student activity rather than one of our department MakerSpaces, or vice versa, that our department spaces are better for them than our library spaces? And I'll let anybody take this one.
I'll take it to start with. Yeah, I would encourage people to use the library Fab Lab before they try to use us, because they have a lot of facilities. They have someone overseeing it. They don't charge hardly anything to use it. And as you see, our labs are pretty small, and people can go over there and just run stuff. They already know how to use it. So I would encourage that to be the first line of defense. They do have a lot of facilities that we don't have, that, you know, we use them all the time. And so I think that would be the first line of use.
Yes, I'm glad you brought that up. The Fab Lab is a wonderful place. If you haven't seen it before, it's definitely worth a trip to the first floor of the library. And that's probably the best place to be introduced to MakerSpaces and the different types of equipment.
Excellent. All right.
I guess I'll add to that as well. Sort of the idea is that a lot of times what I will see students do is they'll have a great idea and they want to go directly from that idea to the thing. okay? And as someone who's interested in manufacturing, the idea is that it's not necessarily quite as easy to go from that concept or idea to a thing. And as a result, we tend to want to run through multiple iterations where we go directly from the idea to the thing to the idea to the thing to the idea of the thing. And that gets very, very expensive very, very quickly. So what I think the engineering makerspaces offer is the ability to actually engineer. And basically we have a set of tools that typically will produce product that you cannot get in the library makerspace. The idea is that what I'm not interested in supporting pretty much is what I would call design churn, where we're just throwing stuff together. I think we need to use these as design products and processes as opposed to craft product and processes. But that's just sort of my humble opinion on that. Well, so we're going to slow you down, we're going to make you think, and we're going to hold you responsible that basically, did the product that you want, did you get what you anticipated? And if not, why not? And you're going to have to answer those questions before we let you do it again.
Nice. So basically, the library is elementary school, and you guys are college. So you go through elementary school and high school, you practice your skill set. The library has lots of training to get initially informed about using the tools. And then after you've gotten some skills, then come to our labs to do the in-depth work. I think that's a great way to use them.
Well, an example might be that they can get 3D components at the library, just like we can in our various labs. What they may not be able to get at the library is basically have in that 3D print embedded carbon fiber, okay? That takes a lot of time, a lot of knowledge, a lot of expense. So if I'm going to put all that time and effort of adding that, I want to make sure that that original print, okay, does its job and basically is fit to purpose. Because I don't want to go to all that effort to embed carbon fiber, to, you know, copper, all this wonderful stuff into that part, only to find out that it wasn't the right size.
Right.
Okay. So a lot of times to use these tools that I've seen right here takes a lot of time and expertise, okay, to do right. And we want to make sure that we're on target so that we minimize the design cycles through each one of these machines, you know, and that's going to take some time and some patience.
Right.
Again, that's what I think. These guys may decide to operate differently.
Well, if I could follow up on what he says, there's first the concept, then there's the analysis to know it's going to work correctly and not break. Then there's the fabrication. If you avoid the center process of analysis, which is what we teach in engineering, you're not going to get a good product the first time.
Right. All right. So we do have another question. This one's for Todd. This is clearly somebody who's very interested in the EE Makerspace. They say, my major requires me to take one EE class. Can I use the Makerspace without charge?
If you're paying a lab fee, then yes. Can you use it for your own personal projects? No, we don't even let our EE students do that.
Right. Right. All right. So there we go. There's our person who's interested in the EE. So,
well, isn't it true? Excuse me, Todd, isn't it true that the Fab Lab actually has PCB mills?
I have not been over there in a while. I would definitely come here for that.
Well, if it's somebody who wants to do it personal, I think they do have PCB mills over there.
We have PCB mills here, and it may cost them $5 for us to produce it for them.
And they're in the
personal.
Yeah, you have some in the shared lab as well as in the EE lab.
Yes, right. Also upstairs.
Right. So
let the dean pay for it.
There you go. Go to the shared lab first. All right. So we are almost out of time. Any last comments that anybody would like to add about the resources that you've shared or students' interest in using those resources?
I'll make a comment. I admire the dean for having the vision to encourage us to have the MakerSpaces and to fund it and to help promote better learning. The only way you really learn something is hands-on. The rest of it, just theory only, is not very applicable. So I applaud the dean for making these available, funding them, and giving the students a chance to honestly learn about engineering and the implementation of engineering.
Yes, we are definitely lucky to have Peter and Peter's interest and willingness to support our students this way. We've always known it's important, but it does take money and it takes dedication and people and time to make that happen. So the whole college is definitely appreciative of that. Any last comment, Todd or Brian, that you'd add?
I would like to say that this is true for all of us, that this is just kind of the tip of the iceberg of the different things that we actually have. We would need probably a day to go over all the different things that we offer our students.
Excellent.
And I guess what I basically need looking at these videos is to figure out sort of how I can best use these resources at the minimum cost to the College of Engineering. And so what I would love to know is we have all this ways of creating 3D objects in the College of Engineering. Basically, is there any sort of guidelines to say sort of you can do this and this is how much it costs, or you can do this and this is how much it costs, so that we can find the best, fastest, cheaper way of doing something, okay, using all the resources spread across the College of Engineering. Maybe you guys know that, but I certainly don't, okay?
And clearly Brian is the industrial engineer in our bunch, right? So yeah, I think we'll take advantage of that.
And I'm the one without the material budget, so I really need to know these kinds of things.
That's right. So we'll take advantage of that skill set to combine more information about our abilities, not just what you can do, but even what it costs to do what you want to do, so that we're all better informed and knowledgeable. One last quick question, and you may or may not know the answer to this. Do you guys have a sense of how we compare to other universities for our resources compared to what other universities have? I know that our MakerSpace is actually, the library MakerSpace, when they set it up, was actually a very well done program that they set up looking at lots of other schools. So I just wondered if you all had any sense of how we compare to other schools.
I have seen a lot of other MakerSpaces from Oklahoma and different places. I think we compare quite well. Looking at some of the more specialized equipment, just browsing the other universities' websites, they may have the same equipment we do, but they don't tell people they have it. So at least what we do is we try to at least inform the students that, yes, we do have all of this equipment and we put it on our website.
Awesome. Bob, did you want to add something?
Yeah, I've seen a couple of other universities, Oklahoma is one of them, that have a shared space for all their competition teams. And some of those spaces are pretty impressive, but I've got to say that there's also a lot of universities that are pretty pitiful at allowing students to get in and do something hands-on. And so this is really great that we do this, but there are some universities that have shared spaces, fabrication spaces for teams, competition teams, but not necessarily for capstone.
Cool. So we are out of time. Again, let me thank you all so much for joining us today and telling all of our students about the resources. I know that I'm actually going to have my Engineering 1101 students watch this video so that they can learn more about these majors that they're getting involved in. And thank you again all for telling us about the resources available. And I suspect you'll be hearing from some students once we get this video posted for them. So Thank you again very much. Thank you, students, for learning about these things. And if you do have questions, feel free to email us or any of our presenters today about with your questions. So thank you again, and have a great afternoon.
Thanks for the opportunity to explain what we have.
Thank you.